You've tumbled into the event horizon alongside John Michael Godier. Music. For this installment, John chats with Professor Avi Loeb. Avi Loeb holds the Frank Bird Jr. Professorship in Science at Harvard University, leads Harvard's Department of Astronomy, established the Black Hole Initiative at Harvard, and oversees the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics. He additionally heads the advisory panel for the Breakthrough Starshot Project, acts as the science theory lead for all Breakthrough Prize Foundation efforts, and chairs the board on physics and astronomy for the National Academies. He's penned 4 books and more than 700 research articles. Loeb is a chosen fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. Back in 2012, Time magazine named him among the 25 most impactful figures in space. Dr. Avi Loeb, glad to have you return to the show. Appreciate the invite. It's a real treat. Dr. Loeb, we've spotted a fresh interstellar visitor, I-3 Atlas. Naturally, it sparks plenty of questions, fascination, and discoveries ahead. Tons to uncover here. But the key, you see, that's the essence of scientific work. It's exciting precisely because it lets us uncover fresh insights. Regrettably, too many researchers lean on prior knowledge when assessing novel findings. For me, the most captivating part, before diving into my main curiosity, which involves pursuing it, is your perspective on its origins. Prior to that, though, estimates of this body's age, drawn from its velocity and path, exceed those of Oumuamua and Borisov, implying within standard models that this substance, regardless of its makeup, dates back around 7 billion years. Does that assessment of its pace ring true to you? Actually, my undergrad student and I published a study on precisely that topic, demonstrating that tracing I-3 Atlas's path, the interstellar interloper detected on July 1, 2025, backward through time reveals its path across the Milky Way spans elevations above the galactic plane linked to ancient stellar populations. It aligns with the thick disk of stars. Extending the orbit further into the past over billions of years suggests it might stem from an aging star. Mind you, this isn't a precise age determination. It's merely that the object's velocity matches the thick disk stars in our galaxy. Yet consider alternative propulsion sources. As we noted in the closing section of our paper with my student Shuk Cruz Kakarov, any such body, if born near a star no matter the ejection process, would carry some launch velocity. So, claiming its rapid pace ties it to the thick disk overlooks potential ejection velocity. Launching it from a youthful star at high velocity would mimic I-3 Atlas exactly. Thus, when experts tell journalists this thing is ancient, they're presuming the initial ejection was modest compared to the observed speed. Hence, it would have adopted the elevated velocities common in elderly stars. But again, it's no age gauge, and it hinges on that low ejection assumption. Remember that, and don't overlook the chance it isn't natural, which we'll explore soon. Absolutely, we'll circle back to it. But on the age aspect once more, merely traveling at high speed challenges the classic view of cosmic motion, where rapid transit supposedly reflects accumulated journey time, shaped by gravitational pulls across the galaxy over eons, equating speed with antiquity. Yet that's not necessarily so, as your race car analogy illustrates, like an Indy 500 vehicle speeding along not from years of wear, but its own engine, fresh off the assembly line. That's a solid analogy. But picture the vehicle equipped with a launch system that flings you out at tremendous velocity, even if the car itself is stationary. From your resulting speed alone, how could anyone distinguish ejection force from the car's momentum? The sole basis for deeming it ancient is presuming the original stellar ejection was negligible versus the 60 kilometers per second at which it pierced our solar system. But that's unproven. Could an unusual orbital setup, say a binary star pair, produce something similar? Example that could hurl objects out at velocities far exceeding our current assumptions? Absolutely. In fact, I authored a peer-reviewed scientific article that proposes the primary way interstellar objects are likely propelled involves precisely this kind of velocity. The process is straightforward. Dwarf stars, which are the most prevalent type, possess roughly 1/10 the Sun's mass and a diameter just a tenth as wide. This results in extreme compactness, as a star's average density is calculated by dividing mass by volume. Since volume grows with the cube of the radius, these diminutive stars boast densities 100 times greater than the Sun's typical density. Interestingly, the Sun's mean density falls just short of typical rock material. Thus, drawing Earth near the Sun wouldn't allow solar gravity to dismantle it before immersion. But approach a dwarf star with Earth, and the star's intense density amplifies the gravitational pull near its surface, overpowering the planet's own cohesion. Consequently, Earth would undergo spaghettification, morphing into a flowing ribbon of liquefied stone. Roughly half the mass from this disrupted body, known as a tidal disruption event, would then be launched into interstellar voids. Upon grasping this possibility, I promptly computed the anticipated launch velocity. It turns out that disrupting an Earth-like world near a typical dwarf star ejects half its material at, surprise, exactly 60 kilometers per second. I pinned that paper in connection to a 2014 interstellar meteor detected by U.S. government satellites, which approached about 60 kilometers per second relative to the Milky Way's local standard of rest. My goal was to identify a realistic mechanism for such rapid transit. This scenario fits perfectly, given the abundance of dwarf stars and the mere requirement of rocky debris nearing one. How might that occur? A massive world like Jupiter could gravitationally nudge inner rocks toward the star, thanks to a process that boosts an inner planet's orbital eccentricity via an outer giant's influence. This dynamic could propel Earth-sized bodies toward dwarf stars, yielding interstellar fragments zipping at 60 kilometers per second. Astronomers might assume such a fragment at that pace originated from the galaxy's thick disk, implying great age. Yet, it could be fresh and freshly boosted to that velocity. We must examine the substance itself. More on that shortly. But first, a quirky query. We know of stars exhibiting extraordinarily high proper motions, even relativistic ones, from encounters with supermassive black holes that catapult them at blistering paces. What's the maximum velocity you imagine for an interstellar object? Might we encounter one vastly quicker? Definitely. Than the already swift Oumuamua. Once more, I produced 2 published scientific studies on stars approaching light speed due to proximity to dual supermassive black holes. Galaxies typically host one at their core, and mergers, frequent events driving galactic growth by combining masses, occur on timescales representing a significant portion of the universe's age. The Milky Way, for instance, will collide with our neighbor Andromeda in a few billion years. During such unions, the central black holes draw together, their binary tightening through dynamical friction against surrounding stars and gas. Eventually, they may near each other closely. Stars caught between them could be hurled out at velocities nearing light speed, especially if the pair is compact. In those 2 papers from about 10 years back, I modeled the expected numbers of such relativistic stars across the cosmos. These escapees would populate the intergalactic medium, the vast spaces separating galaxies, forming a cadre of stars racing up to light speed. Believe it or not, these stars originate from the mergers of black holes right at the hearts of galaxies. I worked out the expected density, how many we'd anticipate in a given space, and figured out that spotting them would be incredibly challenging, since even a brilliant star is tough to pick out across intergalactic voids. However, imagine residing on a world orbiting one of those stars, only to get hurled away alongside it at nearly light speed. That'd be an incredible voyage across the cosmos. You'd zip through your home galaxy in just tens of thousands of years, emerge into the vast intergalactic expanse, and catch glimpses of distant galaxies rushing by. For me, that's the ultimate way to travel near light speed, though building a ship to hit those velocities is wildly impractical. Yet nature pulls it off effortlessly for stars unlucky enough to orbit a binary black hole pair. Dr. Gez, one thing that springs to mind is a truly cataclysmic scenario, like when the Andromeda and Milky Way galaxies collide, bringing their supermassive black holes into play. In tight binary star setups, the pair can siphon energy and gas from one another, stretching into egg shapes as they pull closer. Could something similar happen to the event horizons of supermassive black holes? When 2 get too near, tugging at each other, does the event horizon lose its round shape? Absolutely. It warps significantly, and in the end, the horizons merge, forming a combined surface area larger than the total of the originals. This growth in area from black hole mergers was a key discovery by Stephen Hawking back in the 1960s. Drawing from that theorem he formulated, Jacob Bekenstein, a Princeton PhD student at the time, proposed that black holes might possess entropy, drawing a parallel to how entropy rises under the second law of thermodynamics. His advisor, John Wheeler, remarked that the notion was outlandish enough to ring true. Then Stephen Hawking caught wind of Bekenstein's idea and dismissed it outright, vowing to disprove it with quantum mechanics. But his calculations flipped the script. Black holes do indeed have entropy, which implies they carry temperature, emit radiation, and shrink as they shed mass or energy, accelerating their evaporation until they burst and vanish. That's now known as Hawking radiation, Hawking's crowning achievement in science. For typical astrophysical black holes, though, the evaporation timescale is absurdly long, far exceeding the universe's current age. Only those with masses under about 3 times that of Oumuamua, the interstellar visitor, on the order of a few times 10 to the power of 14 grams, roughly the heft of a subkilometer asteroid, could evaporate within the universe's lifespan if born in the Big Bang. So astronomers have hunted for bursts from such exploding black holes, but nothing's turned up. Still, primordial black holes just above that mass threshold could form the universe's dark matter. They'd linger on, steadily evaporating without fully winking out. We might yet detect their emitted radiation. For perspective, a black hole radiating at the sun's surface temperature would be moon-sized, putting out just tens of nanowatts of power, minuscule. Shrink it further, and the brightness ramps up until it detonates in a gamma-ray burst. No such bursts have shown up, even if dark matter consists of these ancient black holes, though a window remains in the asteroid mass regime that's consistent with observations. It's not excluded, so primordial black holes could well be the dark matter, and someday we might catch their Hawking glow. That'd be a beautifully simple solution to the dark matter mystery, far preferable to some exotic particle or utter enigma. So indeed, things tend to push the boundaries more and more, but you're spot on. Fundamentally, it's a straightforward approach. The real challenge lies in actually forming them, and crucially, that has to occur inside the universe's horizon right from the start. Remember, the horizon marks how far light has journeyed since the Big Bang. As you rewind time toward that event, the universe's age shrinks dramatically. Should the mass or radiation energy density inside a cosmic horizon volume surpass a key threshold, that zone would implode, birthing a black hole. Yet, current observations show the early universe's fluctuations were subtle, on the order of 1 in 100,000. To generate primordial black holes, you'd have to amplify those to roughly unity levels. Achieving such boosts isn't straightforward, and for good reason. Overdoing it would transform the entire universe's mass into these black holes, which we clearly don't observe. After all, the cosmic microwave background held sway over the early mass energy tally. Ideally, we'd channel just a sliver of that radiation into black holes. But that introduces fine-tuning issues. How to craft a mechanism that yields precisely the dark matter we require without exceeding it. It's tough to orchestrate, and no known process pulls it off reliably. That's why I lean toward an elementary particle as the dark matter candidate. Far more convincing. A weakly interacting massive particle, or WIMP, basically. That's been the leading hypothesis since I dove into astrophysics 4 decades back. Dark matter as a WIMP, especially the lightest supersymmetric particle. Supersymmetry, that elegant proposed symmetry in nature, seems so intuitive, sparking all sorts of theories that earned their creators accolades and acclaim. Folks assumed it was real, with the stable lightest supersymmetric particle as dark matter, unable to decay further. Then the Large Hadron Collider probed the expected parameter space for supersymmetry and came up empty. No dark matter particle turned up either. That's a core lesson in science. No matter how dominant the consensus, it's frequently off base, and the path to truth demands data to probe our theories. It seems obvious, right? We gather evidence to vet ideas because nature picks one outcome from endless potentials. Say, I might have had $1 trillion in the bank, or $1 billion, or any number, but reality fixed it at one amount, shaping my life accordingly. So, supersymmetry could have fit neatly in those ranges, yet nature might ignore it. Popularity on social media or in scientific circles doesn't count. Experiments are the ultimate arbiter, slicing away invalid concepts. That's essential because, over the past 40 years in theoretical particle physics, since my astrophysics beginnings, string theory reigns supreme, positing extra dimensions to merge quantum mechanics and gravity via pure math. But after decades, it hasn't yielded a singular, testable theory. This clashes with science's essence. Ideas must face experimental scrutiny, or we can't confirm their validity, leaving us guessing. You could toil 40 years on clever math, flexing intellectual prowess like a gymnast, but true discovery about the cosmos requires linking to real data. Without that, it's just math, not physics. It brings to mind updating beliefs, rethinking assumptions, like the steady-state universe. Some physicists devoted their whole careers to it. Based on the steady-state theory of the cosmos, some folks like Fred Hoyle stuck to it stubbornly, pushing back right up until the finish line, insisting there was never any Big Bang. Right. And it's obvious now that isn't true. Absolutely not the reality. It's crucial to admit when evidence contradicts your hypothesis and step back from it. That was the Vatican's huge blunder, really. When Galileo peered through his telescope and declared, "Look, there are moons circling Jupiter, which means not everything orbits the Earth," the Church responded by saying, "We won't listen, and the people won't either. You're under house arrest." Had they instead replied, "All right, that's your claim, but we'll construct a superior scope, scan the heavens, and demonstrate you're mistaken," they could have shifted gears fast if they'd committed to proving him wrong through superior observations. Rather, it took until 1992, over 3.5 centuries after Galileo's passing, for them to concede he was correct. That admission was mortifying, especially since it came 2 decades post-moon landing by astronauts. At that point, denying Earth's journey around the sun was impossible. You could observe it clearly from afar, via probes in space. So what's the takeaway here? Once solid evidence emerges, it's time to retreat. The truest judge of sound versus flawed concepts isn't flashy equations meant to validate a viewpoint or boasts of superior intellect. Nature doesn't bow to that. The planet has circled the sun for 4.5 billion years, predating the Vatican's founding and persisting long after they dismissed Galileo. Human opinions count for little in the grand scheme. Folks can delude themselves, convince they're the cleverest in existence while overlooking a wiser counterpart nearby. Denying that risk turns into a loop of confirmation bias. If you dodge fresh data, you'll never expose your errors, and that's precisely the approach the Vatican took back then. But it's a short-sighted tactic over time, since others will eventually gather stronger proof. People ventured into orbit and confirmed the Earth's solar orbit. What were you holding on to? By 1992, the only option was to acknowledge, "I erred, Galileo was spot on." You're merely slowing the pace at which we uncover truths about our surroundings. Whether we share the cosmos with intelligent peers, or even sharper minds, has zero bearing on our domestic debates or family chats. We might mock the idea of cosmic company, survey the galactic neighborhood, and assert it's teeming only with simple life forms, echoing much of today's astronomical consensus. Top funding goes to the next big orbital observatory, the Habitable Worlds 1, hunting biosignatures from basic organisms at over $10 billion. Yet there's scant support for probing advanced civilizations elsewhere. The rationale? Picture all those planetary systems as mere Earth-Sun duplicates, with billions scattered across the Milky Way, supposedly harboring just primitive life. We can't say for sure. Positing that beings like us dwell there is a bold assertion, so resources pour into microbial hunts, assuming they're far more common. But try spotting bacteria across the cosmic block from your doorstep. That's a tough endeavor. Contrast that with an intelligent neighbor. They could knock at your door, erect a visible structure out back, lob a stray object your way, or send a delivery to your box. In every scenario, the signal stands out sharply. Though such advanced inhabitants might outnumber microbes less dramatically in this analogy, detecting them proves simpler. My point: we ought to diversify our efforts. Spotting sentience beats chasing microbes in feasibility, even if the latter abound more. Pursue parallel quests with balanced budgets, since breakthroughs could arise anywhere, and stay receptive to extraterrestrial minds. They might well exist. Treating that prospect as taboo only perpetuates our blind spots, though it changes nothing about our cosmic in a skeptical setting. It'll persist anyway. Back in 1992, when the Vatican issued that apology to Galileo, my take was, you've had top-notch astronomical observatories and trials going for 100 years now. The Pope even has a pair of observatory domes right on his residence at Castel Gandolfo, and only just figuring this out? You'd figure, right? Like, you'd expect them to speed up the reconciliation a tad. Yet that's hardly my sole worry. Gazing at the scientific world, I'm genuinely troubled by all this pushback against bold ideas or straying from the usual routes. I raise it here regarding the hunt for smart beings beyond our planet, since, when budding researchers, students, novice experts witness how established figures in academia react to chats on this topic, it scares them off pursuing it, all because they're fretting over career chances. That kind of stifling kills fresh breakthroughs in research. It's basically the surest way to keep us in the dark. And folks out there truly give a damn about this issue. Discovering another advanced society, or one sharper than ours, could reshape humankind's destiny, as they might grasp superior physics. Oh, and it could fast-track solving the puzzle of merging quantum mechanics with gravity. They could hold the key. Might seem like sneaking a peek during a test if we snag it from them instead of cracking it solo. But if it spares us tons of effort, consider we've only enjoyed about a century of cutting-edge science and tech since quantum mechanics and general relativity emerged. They might have clocked way more time, or bigger intellects that let them advance quicker than us. Overall, it's a chance for us to advance, and spotting them could unite everyone too. We'd see ourselves as one human crew on this rock, with others out there, so no more squabbling or slaying over patches of ground here when there's endless territory among the stars. It's awfully short-sighted, really. Like children brawling in a playpen until a grown-up shows up, they quit and grasp. Whoa, there's a whole world past this little patch we're tussling over. That could kick off a transformative phase in our species' development. I view it as vitally crucial. So, much like Blaise Pascal, that math whiz and thinker, proposed, we're clueless on God's existence. But the stakes if he does are massive, so why not weigh that option? I argue the identical for extraterrestrials. The fallout would be enormous. We can't brush it aside sans evidence, without sticking to the scientific process. And speaking of, that process gets overlooked not only by laypeople, but even by working scientists. They botch it. They shut down debates on certain topics. But true science welcomes every inquiry. Throw out whatever hypothesis you like. The trick to sorting if it fits reality? Gather evidence to confirm or debunk it. It's detective work, plain and simple. For that, you chase observable results. So, prioritize queries that experiments can tackle. If you're just spinning mathematical tricks for decades with zero tie to real tests, you're off track from proper methodology. You need to verify if your route's solid. It's akin to guiding a flock of folks down a trail, insisting it's the way, but if it's a dead end unrelated to how the universe actually works, you'll drag the whole group astray. Yet if you let a few scouts check alternative routes, the ones skipped, they could uncover the true direction toward blending quantum mechanics and gravity. Thus, in research, we mustn't restrict the inquiries or guesses overall. Hone in on those testable by trials. But the core of science is pinpointing the right choice via proof. That means pouring resources into hunting that proof. You can't label it a wild assertion to picture peers like us out there, then allocate zilch in government funds to probing for alien minds. That's illogical. You haven't even given it a shot at being disproven. So how could you possibly tell if you haven't gone looking for the proof? How can you call it remarkable without knowing? You can't, because you haven't invested a dime in the effort. So why not allocate the same budget to hunting for microbial life as we do for signs of smarts? Then, after 10 or 20 years, we might actually have grounds to draw conclusions. And if we come up empty-handed, we'll be no worse off than the folks pushing supersymmetry or claiming dark matter is the simplest supersymmetric particle. Turns out they were off base. We poured in the funds, searched high and low, and found zilch. No one holds it against them. That's just how science rolls. But dismissing the idea of beings like us, or superior, existing somewhere out there as some wild notion, all without backing it with resources, that's downright unscientific in my book. The real issue here is the prejudice baked in, And we saw it play out back in 1993 when NASA briefly got some cash for SETI work, specifically radio SETI, scanning for signals from extraterrestrial minds beyond our world. It turned into a political football, with a congressman axing the budget by ranting about little green men and the rest, calling it a total waste. I get the backstory, sure, but honestly, it's ancient history now, decades later. My take boils down to this. Hunting for radio signals is like sitting on the cosmic block, figuring you might have folks next door, and just hanging around for one of them to ring you up. You're basically a bystander, hoping for a ping that spells out a message. Like waiting by the phone, passively. But what if no one dials you? In my case, nobody from my neighborhood has buzzed me since I settled in 20 years back. I spot them out walking, wave hello, but calls to the house. Nah, they're too nearby for that. Contrast that with scouting for something like a stray tennis ball that rolled over from next door's yard. Those turn up all the time. Just the other day, one popped up in my yard from a neighbor kid. Point is, not every item landing in my space is stone or grit. Among the stuff that drifts into my backyard now and then, you'll spot a tennis ball. Purely artificial, no rock involved. So, let's zoom out to our solar system's cosmic turf. Here's the deal with stuff barging in from interstellar space. Whenever we spot an object zipping in from beyond our system, the asteroid and comet pros automatically label it a comet. Take Oumuamua, the very first one we clocked. No gas cloud or dusty trail like you'd expect in a comet's head or tail. Silch around it. Yet now the big shots dub it a dark comet, meaning it supposedly has a tail, just one that's hidden from view. Invisible activity. To keep things in perspective, that thing discovered in 2017 would have had to shed roughly 10% of its bulk to account for the weird non-gravity push we measured on it. We're talking a hefty chunk, not some speck. And the experts insist this lost 10% is all unseen, even as the object itself lit up our scopes. It feels like I'm that child in the Hans Christian Andersen story, pointing out the emperor's got nothing on, bare as can be. But the grown-ups chime in, nah, the outfit's just see-through. And get this, that's the going theory right now. Hard to swallow, right? The establishment insists on an unseen something that turns a plain, visible hunk into a comet. It's akin to calling an elephant a stripless zebra. You might go, fine, zebras are defined by their stripes, so here's a stripe-free one. But that's deceptive on a basic level. Say, for instance, on January 2nd, 2025, this year, a near-Earth object got tagged by the Minor Planet Center as an asteroid, pure rock. Then, overnight, they caught on that its path matched the orbit of the Tesla Roadster SpaceX flung up in 2018. Boom! Out of the catalog it went. Why the flip? They recognized the car. Not a rock at all, a vehicle. My angle? Picture if Elon Musk wasn't the top space pioneer since the Big Bang 8 billion years ago, and interstellar rides were a thing. We wouldn't twig it wasn't stone, lacking the launch details from its home turf. So we'd slap on Comet Sand's visible tail, or just a boulder. Astronomers would have stuck to that without a second thought. Still, what I'm driving at is we need way more intel to nail down what these things really are. Just last month, I rolled out a fresh metric, now dubbed the Loeb scale. There's even a paper on I in the astrophysics catalog. A score of 0 represents a purely natural interstellar visitor, one where we spot a cometary trail or can confidently deduce it's an icy body for various reasons. At the opposite end, a 10 indicates a clear artificial artifact, detectable through maneuvers, transmitted signals, or emitted non-natural illumination, something generating its own glow rather than merely bouncing back sunlight. I've outlined the intermediate values on this spectrum from 0 to 10 as well. For instance, I propose that Oumuamua, the object I mentioned earlier, merits a 4, and the same applies to 3I/Atlas, also a 4. If we detect unmistakable signs of engineering, the rating climbs, whereas firm evidence of natural origins pulls it lower. Science involves ongoing discovery, so I'd adjust my assessment according to emerging evidence. Naturally, we could gain further insights into this latest interstellar interloper, 3I/Atlas, spotted in July 2025 via a 0.5-meter scope in Chile named Atlas, which, incidentally, sits next to the Rubin Observatory, opened in June 2025. The Rubin Group actually identified this newcomer in the lead-up to the official reveal. Thus, this modest instrument outpaced the mighty Rubin setup, an 8.4-meter behemoth equipped with a 3.2 gigapixel camera designed to scan the southern heavens every 4 nights. Projections suggest it might uncover an interstellar object every few months alone. This ushers in a fresh chapter, with potentially several dozen such visitors over the next 10 years. At that point, we could evaluate each one's position on the Loeb scale, from 0 to 10. Should any prove engineered, it would carry profound implications. Imagine if it's an operational gadget. The big query: does it pose a risk to our planet? We constantly discuss perils like rogue AI, runaway climate shifts, or killer asteroids slamming into Earth, yet extraterrestrial tech rarely enters the conversation. Unlike a rock from space, where NASA's planetary defense team tracks near-Earth objects and computes collision odds via orbital mechanics and gravity's rules, a crafted item defies simple prediction. It might alter course deliberately or follow hidden objectives. Countering that demands a wholly distinct strategy. I'm not anticipating hasty moves until we have solid proof of a full 10 on the Loeb scale. That would trigger an urgent global alert. We'd promptly form a worldwide body drawing experts from every nation. Since extraterrestrials won't respect our earthly borders, an event in one spot could swiftly affect others. Humanity must unite. No state or group exploiting the situation to target rivals. Drawing on every observatory, satellite, and orbital resource available, including those tied to defense, we'd redirect them towards scrutinizing the inbound anomaly. Policymakers would then craft responses grounded in those observations. Preemptively dictating actions is impossible without specifics. Our tech visions are bounded by familiarity. As I noted, something originating from another star reshapes everything, possibly unveiling innovations beyond even Hollywood's wildest sci-fi dreams, surpassing our current scientific grasp. Reactions would hinge on the intruder's traits and motives. I suspect such an event would transform humankind's path, prompting debates on handling future visits. We might deploy a network of probes across the solar system to watch for arrivals, notifying Earth of any engineered threats approaching. An interception protocol could emerge for urgent dangers, debating nukes or opting for open greetings. Picture an unknown figure lingering in your yard. You'd huddle with loved ones to figure out next steps. It's far removed from receiving a distant radio transmission or a call from afar. In scenarios involving a broadcast from some distant point, that's thousands of light years distant, so we've got ample opportunity to figure out our response. There's no rush for an immediate danger. However, if a guest shows up right in our neighborhood, that guest could arrive at the main entrance. You'd need to react right away on how to handle it. That's an entirely distinct scenario. The point here is that the approach the SETI folks took before, basically sitting by the phone or scanning for radio waves, differs greatly from today's possibilities, like spotting interstellar visitors and examining if any carry signs of technology. Should one turn out that way, it would reshape our perspective on the cosmos. It could alter our ambitions for exploration. We might even set out for other stars. It would transform absolutely everything. Imagine, for instance, this fresh interloper 3I/Atlas as it nears the Sun most closely on October 29, 2025, if it adjusts course and uses a slingshot boost from the Sun, similar to how our probes often do. In that scenario, if it's aiming to accelerate, it'd do so best right near the Sun. Incidentally, we won't catch sight of it then, since Earth will be on the far side from this object 3I/Atlas during its solar close approach on October 29. Yet if it emerges from the opposite direction than anticipated, the financial markets could tumble. Before diving straight into 3I/Atlas and methods for tracking it, even when it's hidden behind the Sun from our view, though we have probes elsewhere, let's consider the odds of activating the Vera-C Rubin Observatory for its wide surveys, which should snag numerous interstellar wanderers, building a solid sample for analysis in the years ahead. But what if, recalling the buzz around Oumuamua's flyby, with all those wild theories we covered in earlier episodes, granted, it was our inaugural sighting and downright odd, as you highlighted. It stood out, but we ought to encounter plenty more like it. What if the Vera-C Rubin fails to detect any additional ones with such bizarre traits? What does that imply? Why was it a one-off? Sure, for natural bodies. You run the numbers. I surveyed the heavens with certain detection limits over a 10-year span and spotted one. That suggests a high chance of uncovering more similar ones in future decades. It's straightforward math. It doesn't guarantee discoveries, but with gear boasting superior reach to probe larger swaths of space, the tally of finds for objects on erratic paths will rise proportionally to the searched volume. No escaping that logic. The Rubin facility outclasses the Pan-STARRS setup that first nabbed Oumuamua. So if it misses any Oumuamua-style items despite its expanded scope and sensitivity, that would render Oumuamua even stranger than before. Just a note, it was rotating or flipping every 8 hours, with reflected sunlight varying by a factor of 10 during each cycle. There's a thorough study that modeled Oumuamua's form, and the top match at 92% confidence level was a pancake-like thing, a thin disk. It wasn't merely odd due to non-gravitational push. Its outline was peculiar too. And look, when something appears off, we should own it. Don't claim it's got a comet tail that's just out of view or composed of hydrogen or nitrogen ice. We've never observed ice chunks from those. If our debut interstellar find acts so unusually, that quirk must be typical. My stance is, let's nurture that wonder. Keep it burning, instead of sweeping oddities beneath conventional assumptions. Surprisingly, some experts, particularly in the SETI circle, fiercely reject entertaining Oumuamua or 3I/Atlas as anything beyond a comet or rock. They're dead set against exploring that angle and argue we should stick solely to hunting distant electromagnetic beacons for alien societies. I just can't wrap my head around it. Since dark matter hunters debate all sorts of candidates, we touched on a couple: weakly interacting massive particles and ancient black holes. I've attended numerous gatherings discussing dark matter's essence, and I never once caught the primordial black hole proponents claiming they refused to hear others out. They weren't blocking sessions at their events about the idea that dark matter consists of weakly interacting massive particles. Nothing like that ever came up. Yet, the SETI folks established a policy to avoid addressing nearby Earth objects during their meetings. There are these unidentified anomalous phenomena, unexplained items zipping around. Their origins remain a mystery. That topic gets outright excluded from SETI conferences. So, could there be some profound underlying dread, an ontological terror, stemming from the shock of realizing an extraterrestrial society might be nearer than anyone imagined? Folks often throw around stats and argue, what's the likelihood of one being right beside us, or whatever? But we lack knowledge on the actual guidelines. We have no clue about alien behaviors, precisely, or how they'd operate. Right. Spot on. I mean it truly. So, allow me to demonstrate with the case of 3-2 Atlas. Alright, when 3-2 Atlas got detected and revealed, that evening I actually had to rise at 2 a.m. since I was appearing on Coast to Coast, and a viewer messaged me regarding this thing. The moment I grasped its luminosity, I computed its potential scale if it were a solid body, how large it would need to be. I determined it would require a 20 kilometers diameter to bounce back sufficient sunlight, assuming a standard albedo of 5% that's common for asteroid rocks. And 20 kilometers is enormous. Larger than Manhattan Island. Double the dimensions of the impactor that wiped out the non-avian dinosaurs 66 million years ago. Moreover, based on interstellar wanderers like Oumuamua, you should anticipate around 100,000 such items, if both Oumuamua and 3-2 Atlas are just rocks, drawing from the counts in our solar system's main asteroid belt. For every Oumuamua-sized visitor, you'd expect 100,000 reaching 20 kilometers across like 3-2 Atlas. Yet before spotting 3-2 Atlas, we hadn't detected 100,000 Oumuamuas. There was just Mua, followed by Borisov, and now 3-2 Atlas. That's all. It left me deeply baffled. On July 4th, merely days afterward, my spouse insisted we take a trip. Naturally, I couldn't step away since I drafted an article pointing out, you see, it's not merely the quantity issue. If you figure the amount of rocky debris that ought to float in interstellar voids per cubic unit, and then bundle it all into 20 kilometers chunks, picture this. Suppose every bit of that cosmic gravel gets shaped into 20 kilometers boulders. Then you'd only encounter one in the inner solar system every tens of thousands of years. But we've scanned the heavens for just a decade and already spotted 3 like 3-2 Atlas. so it simply can't be a 20 kilometers stone. Interstellar space lacks sufficient rocky stuff to deliver them to us that often. And this mismatch spans orders of magnitude, far beyond a mere factor of 2. Yep, absolutely, it'd take centuries. You'd catch sight of something that massive only every millennia, say 10 millennia. The previous visit from such a visitor would predate human records, think 10,000 years back. And that's under the most favorable scenario of clumping all the rocky matter into those forms. So I concluded it doesn't add up. Naturally, one option I proposed in my write-up was that the core of this visitor is way tinier, under a kilometer, and it's enveloped in a dust envelope that scatters light. Thus, what we're observing is mainly the glow off that dusty haze, similar to how comets appear. Then I added a wrap-up line. The other option is that this entity aimed for the inner solar system intentionally. The editor responded, "We'll run your piece provided you excise that final bit." And I reflected, isn't that astounding? A single phrase in an article rattles the editor enough to reject the whole submission unless I drop any hint of it being artificial and deliberately heading our way. But as the maverick I am, that incident spurred me to produce an entire study exploring the chance it's artificial. In the end, it evolved from a lone sentence into a complete publication later on, co-authored with my collaborators Adam Burt and Adam CRA from the Initiative for Interstellar Studies. In that work, beyond my point that the thing couldn't be so gigantic, and if it's no comet, it might be artificial, especially since it zeroed in on the inner solar system. Its path into our neighborhood bears no link to the interstellar rocky reserves. It has zero connection to that supply because it was directed toward the inner solar system. Interestingly, the path of 3I Atlas shows remarkable precision, aligning perfectly with this concept. It precisely rests within the orbital plane of this object around the Sun, aligns with the planet's plane to within 5 degrees. There's a 3D illustration that depicts the path of 3I Atlas, revealing an entity approaching from immense distances and positioned in sync with the planetary lineup. The odds of such alignment occurring by pure chance stand at 1 in 500. But let's say you dismiss it as a rare fluke. Miracles do pop up occasionally, after all, and chalk up this path to sheer luck rather than intent. Yet, you can tweak the timing of its approach. Remarkably, the arrival along this route is finely calibrated too. Consider the paths of Mars, Venus, and Jupiter circling the Sun nonstop. This thing, 3I Atlas, draws remarkably near to each of them. The probability of that with a haphazard entry time? 1 in 20,000. I thought, hold on now. This path might indicate deliberate planning to skim past these worlds, perhaps deploying small probes for planetary flybys or scouting runs. My next idea was even better. It'll swing by Mars. We've got orbiters and probes hanging out there that could observe it. There's a half-meter resolution camera called HiRISE primed to capture images, and just yesterday, I reached out to its science team, urging them to target 3I Atlas during its Mars close approach on October 3, 2025. Then, on March 16, 2026, 3I Atlas will near Jupiter. A probe named Juno, sent up in 2011, faces a planned dive into Jupiter's atmosphere around mid-September 2025. I pinned an article proposing we redirect it instead, nudge Juno clear of Jupiter so it intersects the route of 3I Atlas, allowing a rendezvous or at least a nearby pass, based on remaining propellant. Our calculations showed that even with just 10% of its starting fuel, Juno could approach within 25 million kilometers of 3I Atlas in mid-March 2026. With its full original fuel load, an actual intercept was feasible. You ran the numbers on its propellant consumption and figured it still has plenty on board, didn't you? Yeah, I chatted with the Juno crew too, asking for their fuel assessment. But right after I sent off my paper for review, Congresswoman Anna Paulina Luna called me for a briefing on 3I Atlas. I shared the study with her, and she kindly offered to send a note to NASA's director, pushing them to explore redirecting Juno for a 3I Atlas encounter. I'm truly thankful for her foresight. In the big picture, comet specialists label 3I Atlas as a comet. It originated from the Milky Way's dense core, packed with stars, a smart origin if evasion was the goal, which explains why we only spotted it in July 2025. Plus, it follows a retrograde path, meaning any released subprobes would travel counter to the planet's orbital flow, making encounters straightforward without pursuit. That retrograde setup, synced to the solar system's plane, struck me as the object's most bizarre trait. As for its comet status, multiple groups hunted for gas signatures around it, but found no traces of typical carbon compounds or oxygen typical in comets. The sharpest view came from the Hubble Space Telescope, showing a tight, glowing haze stretching to about 10,000 kilometers, shaped like a comma often linked to comets. But it's ahead of the body, not trailing behind. No cometary tail in sight. The object's spectrum appears reddish, echoing sunlight bounced off material. Sure, comet dust ejections could redden light if particles match visible wavelengths, around half a micron. But solar radiation pressure would scatter such tiny bits in a day, I figured, forming a trailing dust stream we'd easily detect, like the bright tails common on comets. We see nothing of the sort here, no prominent dust trail. Objects like this one feature stars that are obscuring things behind them. The big puzzle is, why? Another intriguing aspect comes from the Hubble Image Analysis paper, specifically Figure 3, which displays the brightness profile near the core as projected across the sky. There, the intensity drops off inversely with the angular distance from the center to the power of 3. That's way sharper than the typical drop seen in comets, where it's usually just inverse to the angular distance. You can explain that one easily. With a constant stream of dust ejecting from a comet, the dust density decreases with the square of the distance, and when viewed in projection, the brightness fades inversely with distance. That's a common pattern for comets. Here, though, it's cubed, meaning in actual three-dimensional space, the brightness diminishes inversely with distance to the fourth power. So how does that happen? If dust is outflowing with density falling off as 1 over distance squared, and there's a central light source whose illumination decreases as 1 over distance squared, then scattering that central light off the escaping dust combines to give you 1 over distance to the fourth. Is 3I/Atlas producing its own illumination, or just bouncing back sunlight? That's the focus of my upcoming research paper. These are fascinating puzzles to tackle. There's something odd about this object's brightness distribution. There's oddity in its precisely tuned path, and it's strange not spotting a cometary tail trailing it. All I'm suggesting is that we keep observing it closely. If it's a comet, getting nearer the sun should heat it up, leading to outbursts of volatiles, dust grains, and gas, plus a stunning tail developing behind. But if it's not, none of that will occur. So, we ought to avoid jumping to conclusions that it's like the familiar comets in our solar system too soon. That happened with 2I/Borisov, which resembled the comets we're used to. This one, at a comparable distance from the sun, doesn't resemble 2I/Borisov at all. Let's keep watching and determine if it's a 0 on the artificiality scale, or perhaps a 10. With this interloper, I've got two main queries. First off, it's swinging relatively close to 3 planets in our star system. But if it had launched sooner from a slightly different direction, it could have capitalized on something akin to the Grand Tour setup from the 1970s and 80s. Coming in from beyond the solar system, you might have grazed several inner worlds, and with the outer giants lined up, at these speeds, and using gravitational slingshots between planets, you could have visited far more than 3. Why the delay in arrival? Perhaps it didn't delay, maybe it passed through earlier. The thing is, we've only had the sky surveying tech in place for the last 10 years or so. That's why every interstellar visitor has turned up in that time frame. Obviously, this isn't some brand new event starting now. It must have occurred before, but without the advanced monitoring gear we have today, and lacking the powerful computers to crunch the data, we simply overlooked it. The timing might even hint at curiosity from an extraterrestrial society toward us, since we've been beaming out signals announcing our presence without much caution. Over the last century, those transmissions have reached 100 light-years. Now, consider when 3I/Atlas crossed into the outer edges of the Oort cloud, the solar system's distant frontier at 100,000 times the Earth-Sun distance. That was about 8,000 years back, based on its observed velocity. That's precisely when humans began recording their histories in writing. And that's if it originated from way out there. If it started from just 1,000 times the Earth-Sun distance, the trip would have taken 80 years. From 100 times that, only 8 years. It all hinges on the launch point. Naturally, if it's a regular comet, as we've touched on earlier, it might have begun its voyage 7 or 10 billion years ago. For context, Oumuamua was nearly stationary compared to the Milky Way's local standard of rest when it entered our system. The solar system essentially collided with it. That was a peculiar detail. Using the same method my student and I applied, our analysis showed that if Oumuamua were a natural body, that object hailed from a star, so it likely sprang from a youthful star that's just around 1 billion years old. Then there's 2I/Borisov, the second interstellar visitor, which was a comet, and it fell somewhere in between Oumuamua and 3I/Atlas regarding velocity. It might have come from a group of stars roughly the same age as our Sun, about 5 billion years. In essence, we've snagged examples of 3 distinct velocities, each quite dissimilar. From my perspective, 3I/Atlas stands out as the quickest by a wide margin. The core puzzle here is, what makes it follow this unusual path? Typically, interstellar wanderers like Oumuamua or 2I/Borisov arrive at steep angles compared to the ecliptic plane of the solar system. But this one showed up right along the ecliptic plane. Yeah, it's odd that it lined up so precisely with the ecliptic, even if it's off by just a few degrees, something you wouldn't encounter frequently. And yet, here we have it. You know, the odds are about 1 in 500 or a few hundred. The key is, we hadn't spotted hundreds of objects like 3I/Atlas before this one popped up perfectly aligned. We only had this single aligned case. It's the speediest mover, lacks any cometary tail, and swings near the 3 inner planets. So I say, let's keep tabs on it. Let's stay focused. I reckon that's a fantastic suggestion, especially since it's not solely Juno in play. Juno's basically wrapping up its mission anyway. They're planning to deorbit it and plunge it into Jupiter. Why not repurpose it while it's still functional? I came across Anna Paulina Luna's letter, and I thought, hey, that's solid. Pushing for it in Congress makes sense. Absolutely, but let's not overlook Mars either. I'd love your take on leveraging the probes we already have there, like MRO, to collect more data on 3I/Atlas. Sure, MRO packs a ton of tools, including a half-meter telescope called HiRISE, and I recommended to the team that they target 3I/Atlas on October 3rd as it nears Mars. Fingers crossed they'll go for it. They seemed receptive, though challenges exist with its approach direction and rapid motion. But overall, they're geared up. They're seriously considering zeroing in on this thing then. And remember, we need to stay locked in. Like hoop players say, keep eyes on the prize. Ignore the social media buzz, the crowd, the thumbs-ups. It's all about zeroing in on 3I/Atlas. Definitely, just observe it. It's passing right by. Make use of it, particularly with gear that's nearing the end of its run. Utilize those resources. I figure NASA will step up, as they often do in these situations. To be fair, they deserve credit for jumping on opportunities like this. It wouldn't shock me if they redirect those instruments, or at least snap some shots. But let me probe further. With Juno at Jupiter and its full suite of sensors, what measurements could we grab if we maneuvered closer? We could detect high-energy particles, map magnetic fields, and attempt to snap images of the area around it, based on our proximity. Overall, it'd be a huge win for NASA, given the massive public buzz. And that's a crucial angle here. Some SETI folks and academics have been knocking it, claiming ditch Juno. It's unremarkable, low on fuel, won't yield useful data, better to stick to Jupiter scans. That kind of brush-off attitude, yeah, but it'll only scan Jupiter for another 8 days or so. Exactly. But it highlights the mindset of certain individuals. They prefer to skip it entirely. I find that baffling, since the public is hooked. Over the last 10 days, 250,000 folks have dove into my Medium essays. 250,000, mind you, not quick tweets. Interest is off the charts. I field hundreds of emails daily, loads buzzing with thrill over spotting 3I/Atlas. This is a golden chance to draw folks into science, spark kids' curiosity. It's everywhere. Take our porch repair guy. He pulled my wife aside and asked, "What's Avi working on now? Any updates on 3I/Atlas?" I'd never even crossed paths with him. So she called me out, and I handed him a signed copy of my book. He snapped a selfie, hands trembling, and goes, "Man, I'm jittery standing by you. I'm that pumped about this thing and tracking all your updates." Someone else mentioned joining me on a Zoom during a sports we were at this spot in Santa Barbara. Once he wrapped up his chat, a person approached and remarked, "You brought up Avi. Is that Avi Loeb? It's unbelievable you were talking to him." Folks in Spanish-speaking nations, numbering in the millions, go through versions of my writings about 3 Atlas. And just this last week, I've been handling roughly 6 to 8 spots on TV, radio, and in print each day. My goal is to share the thrill of scientific discovery, grounded in solid proof, tackling captivating inquiries. A lot of those detractors just aren't getting it. Some come from folks who haven't put out even one research article in the last 10 years. They're just online commentators or video creators slamming talks about a potential tech-based source. Meanwhile, in the previous month alone, I've released around 12 peer-reviewed studies, while they've gone a full decade without a single one. Still, they're out there trying to protect science from who exactly? From those actually doing the research. I'm right in the thick of it, grinding away on the experiments. Plus, I make sure to explain it all to everyday people, since I believe that's key. It could spark interest in kids to pursue science once they see how we tackle intriguing puzzles their folks ponder, all via rigorous methods. So, we're not certain yet if it's a comet. We'll determine that through observations. That's the sort of inspiring takeaway you can't get from, say, dumping $10 billion into the Large Hadron Collider and touting a fresh particle find. Sure, you spot something new, but you're revealing it post-discovery. The audience skips the journey, misses the meaning, and it doesn't touch their daily lives. But should 3 Atlas turn out to be an artificial scout, it'd transform everything for humanity. It'd reshape the path of research, faith, you name it. I once had a bunch of theology experts visit Harvard to chat with me. They were with this group, called Christianity Today. They posed, if we encounter aliens, would that shake our spiritual convictions? I replied, look, I've got 2 girls, and the arrival of the younger didn't diminish my affection for the elder. Picturing the divine as a guardian limited to just one offspring feels way too narrow. You'd be thrilled to discover numerous societies. We'd be like added family. The real snag? If we're kin, we might envy the one that's way ahead of us in achievements. That stuff crops up with actual brothers or sisters who outshine you. Sure, envy might sting, but beyond that, it's proof of your folks' skill in raising a brood and handling the chaos. Yeah, but when you... Alright, I'm no believer myself, obviously. I can say they bought into it. They left quite pleased. Well, my mind jumped straight to it. If such a force exists, I'm like Einstein, viewing it through Spinoza's lens and all that. Still, by nature, it'd be all-powerful. Wait, no? The core issue, even if you embrace Spinoza's idea that the cosmos equates to the natural world, boils down to, does that world encompass multiple intelligent species, more than one advanced society? With billions of stars like our sun out there, would that pose a problem? Nope. No matter the divine idea you hold, there's no snag in that mindset. It can manage everything. So that's it. It's all-knowing, everywhere, right? Capable of juggling it all. Exactly. That bolsters my point even more. If you see it as engaged, the divine actually watches over us. It could nurture kin just like parents do. Encountering our cosmic relatives in the Milky Way would enrich us hugely. We'd gain so much wisdom from them. Unless you cross paths and discover they've got their own faith system, worshipping figures like Zeus or Hera or whatever. Stumbling into a faith clash with extraterrestrials? That wouldn't go smoothly. It never has among us humans. Oh, but that's the same risk with a long-lost sibling sharing your genes, raised apart from the clan. They could evolve totally different outlooks on existence and such. Naturally, that'd need hashing out. And remember, we can't predict if incoming tech vessels in our solar system mean well or harm. The best way to learn? Send signals back and forth, or gather clearer intel. It gives a better grasp of the tech scope. For instance, if it's merely an item zipping through our solar system and heading off, and they're simply observing whatever crosses their path, it's akin to a vehicle cruising along a freeway. You allow it to go by without fretting over its impact on your residence. Ultimately, it hinges on its actions. From my core viewpoint, we're not all that significant. That's the insight Galileo and Copernicus delivered. Humanity isn't the universe's focal point, and perhaps we're not its intellectual hub either. They likely disregard us entirely. We've only emerged in the last few million years, while their voyage kicked off billions of years prior, long before our time. They're just traversing the area, seeking knowledge along the way. We struggle to comprehend it fully since they've reached our cosmic turf ahead of us, venturing into theirs. Thus, They're apt to be far more evolved or have had a greater head start. In essence, I'm suggesting we keep watch on events unfolding in our stellar neighborhood and cosmic yard. Rather than presuming we grasp the outcome up front or twisting logic into knots to fit preconceptions, let's determine if we've got savvy neighbors. This flips the script from string theory approaches, where you posit additional dimensions, yet can't verify them experimentally. Here, you propose a hypothesis testable by scanning the heavens, and the prime candidate is Oumuamua. Yeah, examine those other interstellar visitors. The soul barrier? Doubters insisting we skip the gaze because we already know it's a comet, and how dare anyone entertain alternatives? Still, I can't ignore that. You brought up the Copernican principle, so I must follow it. I don't view myself as a one-of-a-kind mythical creature. Human society isn't some cosmic anomaly, and I reject the idea of total isolation. Fundamentally, I believe solitude is improbable. That spot on mirrors my stance precisely. A few years back, the Polish authorities asked me to speak at an event honoring Copernicus's 450th birth anniversary in his hometown, Turin. My presentation was titled The Next Copernican Revolution, echoing what you described. It's tied to the principle of mediocrity too. I refuse to imagine that I'm exempt from the statistical norm encompassing similar instances across the cosmos. So why treat technological human advancement as an outlier? I can't fathom that. It doesn't imply scarcity overall, though rarity might apply temporally. There's the timing factor. You might not overlap with another society within detectable range. But that hardly matters for swapping interstellar debris. Take my example of the Elon Musk-launched Tesla, dispatched eons ago, now drifting into our solar system. There you have it. That car boasts a far longer endurance than any person. We lack insight into human society's duration or that of extraterrestrial ones broadly, but if they endure for millions of years, their discards will litter the void. Envision Pepsi cans hurtling through star systems. Not such a far-fetched notion. What ties all this together is a call for modesty. Humility urges us not to claim foreknowledge or pose as the wise authorities dictating routes. Instead, we ought to probe various avenues. Sure, hunt for radio waves, but also check for deliveries in our cosmic inbox. Probe for simple life forms, yet simultaneously seek out advanced intelligences, since we can't predict what's simpler to spot. This humility stems from genuine inquisitiveness, embracing openness without favoring one likelihood over another. The sole path to truth lies in gathering evidence. That mindset also challenges self-proclaimed authorities who dictate truths to the masses. Folks are increasingly weary of experts pontificating at conferences or briefings about what you must accept, especially when those assertions later prove flawed. We witness this in scientific funding dynamics, rife with echo chambers, review panels doling out grants to cronies, shunning anything off the trodden trail because they crave financing for whatever projects catch their eye. And let's face it, that's a tight-knit loop. There's no real monitoring on where the money flows or how groundbreaking the research truly is, or even if alternative routes are getting a fair shot. Nope. When the so-called authorities declare that this avenue deserves attention, everyone piles on board. And if, after all that, we strike out on supersymmetry at the Large Hadron Collider, fine, we took a detour, but at least we can say we gave it a go. But what about the roads not traveled? What about fresh takes on quantum gravity? What about broader strategies for SETI? Not limited to radio waves or electromagnetic pulses or laser beams, but actually scanning for probes dropping by our neighborhood. Why ignore that angle? We'd never spot what we're overlooking without poking around. That calls for a dose of humility, right? It involves dropping the act of being the wise grown-up in charge. Instead, approach it like a curious child, marveling at the cosmos and ready to absorb fresh insights. You see, glancing back at ancient faiths, they all revolved around this idea of a superior being out there, reminding folks they're not the ultimate power. Then Friedrich Nietzsche proclaimed God is dead, kicking off a century-plus of scientific and tech advances, and suddenly we've got this arrogance that positions us humans as the pinnacle of existence. But that illusion of dominance is about to shatter, thanks to our own inventions. Artificial intelligence, just a few decades away, could boast superhuman smarts and cognition, forcing us to admit we're not the bosses anymore. A creation of ours outstrips us entirely. And before that hits, we might encounter extraterrestrial minds far beyond our own, but only if we're truly receptive. Either way, it'll humble us. We're nowhere near the apex of the chain. So, yeah, embracing that modesty is key, and the prime way to build knowledge is through solid proof and observations. But if you're convinced you already have all the answers and skip the evidence, you'll stay blind to your mistakes. Coming from my background as a sci-fi writer, I gotta say the wildest concept is that if something's lurking out there, it might be around to halt our push toward AI that could bolt from Earth and endanger the stars. Like a cosmic patrol operation. No dice on that tech, they'd say. We're intervening for your sake. But honestly, if they're invested in us, that's one thing. My hunch. We ought to seek them out for sparks of genius to elevate our game. We could use exemplars way better than the mess in global politics. True guides might hail from distant suns, and that's the real payoff for us. It's not like they depend on our presence. I figure they barely notice us, and any flyby has its own motives. Still, we stand to gain by observing and adapting. So, with that humility in mind, recall Enrico Fermi's 1950 lunchtime query at Los Alamos about extraterrestrials. Where is everybody? That's the cry of isolation, echoing what anyone feeling alone wonders. Where's my match? The advice for the solitary soul? Don't assume you're irresistible. Get out there, peek through the blinds for signs of life next door, hit up the apps, take initiative. And on the massive timelines and expanses the universe throws at us, they're immense. For us to suppose we're the crowning achievement, when the Milky Way alone hosts billions of Earth-like stars around sun twins, plus trillions more galaxies in the observable cosmos, and who knows beyond the edge, that's pure fantasy. I recall my girls as toddlers, convinced they orbited everything because, in those early days, their world was tiny, like a dataset for a basic AI model. Their smarts stemmed from that narrow bubble. Babies figure the universe spins around them, surrounded only by home and parental focus, so they feel like the stars. As they matured, they glimpsed neighboring homes from the windows and realized others existed. But it took time to grasp that those places held people and children just like them, worthy of equal care. The surprise hit on the very first day at kindergarten when they spotted tons of other kids just like them, some even more gifted, and as a society. Plus, folks in the academic world, we haven't grown up in our outlook yet. We keep debating whether we could be, the sole example out there, and the cosmos is genuinely, this unusual event centered on us, sorting it all out, similar to how my daughters did as babies. I just point out it might not hold up, considering the stats. We ought to stay humble. We should embrace a bit of universal humility. Dive into the cosmos with wonder rather than rigid beliefs. The surefire way to spot the gap between a rigid thinker or a conspiracy buff and a true researcher is to hand them heaps of information. The conspiracy buff or the rigid one will get really anxious about it, since any facts or proof you provide might clash with their convictions. But a real researcher will be thrilled. The more info, the better, even if it challenges what they previously assumed, because it's all about gaining knowledge. We gain from the info. We gain from the proof. Science history shows we've been mistaken plenty of times. The accepted view was off base. Just consider quantum mechanics on its own. No one saw it coming. No one requested it. It shocked everyone that the physical world operates in non-predictable ways. Quantum setups display entanglement, that eerie distant effect, as Einstein called it. He personally struggled with it. It wasn't obvious how to make sense of it. And forget about anyone anticipating it in the first place. What does that mean for us? It means if you set up a study framework where you already know what you aim to find, you won't uncover a thing. Why? Because major breakthroughs are always the unexpected ones. So, foster some humility and pursue varied routes to the truth. And what's more, be open to absorbing ideas that contradict your fixed ideas or framework. Let an object entering our solar system be whatever it is. It doesn't have to be a comet. Let's see what the evidence reveals. And let's gather that evidence. Now, I've got two last questions, but I need to toss out an observation first. If you encounter extraterrestrial smarts, a superior mind that's not organic, it could, to drive this point home again, simply be present because we're building artificial intelligence. We might not matter much, but the AI does. And suddenly, Human society watches as the extraterrestrial mind zips away with ChatGPT into the stars, right? And everyone in our civilization is left going, was that it? That's actually a sharp observation. In fact, Martin Buber, a thinker who worked at Princeton University about 100 years back, outlined three kinds of encounters then. One involved people engaging with things, another people with people, and since he was spiritual, he included people with the divine. But clearly, computers and AI weren't around in his era. And what we're facing today adds new layers. Interactions between humans and AI with other AI. Imagine how rapidly AI would evolve if it could refine itself and connect with fellow AI without humans meddling. Ultimately, there's AI crafted by humans meeting AI from aliens. By the way, extraterrestrial smarts are likely AI too, so we shouldn't shorten it. And, of course, if both rely on silicon, the human-created AI and the alien one, they could bond more closely with each other than with us flesh and blood types. And, as you mentioned, it might actually assist us. Our own AI could aid in deciphering any signals from a visitation, since, our minds might not be sharp enough to crack it, much like the Enigma cipher in World War II that Alan Turing and machines helped unravel. In theory, we might require a super advanced AI of our own making to decode alien AI. If they could, because I wager that cracking the Enigma was 1 feat, but breaking the Navajo code? No one ever managed it, as we built it on tongues like Navajo, totally unrelated to any living human languages. At a certain stage, without the key, it's nearly impossible to solve, and we luckily possess the key. But I doubt that code was ever cracked. Right? Yeah? So cryptography is a skill that down the line could be overtaken by quantum machines, which function so unlike standard ones. And and of course the big question remains. What tools do these extraterrestrials rely on, and how intricate is their communication system? It's a fascinating topic, and once we come across a working gadget from them, it'll unlock fresh paths for exploration. I'm optimistic it could motivate us too. Imagine grasping that they've journeyed across the cosmos to reach our world, while we're grappling with all sorts of doomsday threats back home. That might push us to launch a spacecraft crewed by people on an extended voyage to distant spots. Sure, it's no easy feat, but it strikes me as way more exhilarating than heading to Mars. Why is that? Mars is basically just a barren chunk nearby, lacking any real air, battered by sandstorms, with surface temps swinging wildly by hundreds of degrees. No shield against radiation up there, and survival might demand burrowing into some cavern. What I'm getting at is, shifting from Earth to Mars, impressive as it seems, feels like starting life high in the treetops of a forest and spotting another branch not too far off, thinking, hey, that one could offer more options. If trouble hits our spot, we ought to claim it too. Hopping to another lifeless orb is pretty much the same deal, but it doesn't tackle the bigger, enduring challenges. Think about it. We climbed down from those jungle canopies long ago, and after millions of years, we're now thriving in towering skyscrapers across global cities. That shift from forest limbs to urban towers marked a huge evolution, a whole new way of existing where essentials are right at hand. To me, leaping from a bustling metropolis to orbital outposts feels like a smaller jump than that ancient one. Looking ahead, we ought to map out thorough strategies for crafting space-based homes, not mere outposts like the current station, but real settlements for permanent living that can cruise vast distances. That vision excites me far more than picturing a massive booster hauling folks to the Red Planet, since arriving there means facing an even tougher, less welcoming setup for survival. Why commit people to a suicide mission loaded with lethal hazards? We can do better and craft something akin to Noah's vessel. In my writings, I call it Noah's starship. I even covered it in my novel Interstellar. It'd serve like that biblical boat, rescuing key fragments of our species into the void, maybe even beyond our solar system. This is for down the line, of course. Our sun sparked to life about 4.5 billion years back, smack in the final third of the universe's timeline. That's precisely 1/3 of its total span. So, we're relative newcomers. The bulk of stars ignited eons earlier. We spot them twinkling in the Milky Way and can pinpoint their ages. Plenty of sun-like ones predated ours by billions of years, meaning the cosmic gathering was already in full swing when we showed up. Consequently, Advanced societies could have thrived way back then. The classic puzzle, where'd they all go? If you pose that about us Earthlings, consider there have been roughly 100 billion humans over the last few million years, most long gone now, leaving just 8 billion breathing today. The others? Dust. That pattern might apply elsewhere too. Those ancient groups not only arose long before us, but could have faded out by this point. Still, a few might endure, particularly those who dispatched envoys to the stars. If we're set on enduring as a legacy of human ingenuity, we should aim higher than nearby jaunts or claiming spots like Mars. We need arcs with multi-generational crews venturing into deep space. This concept echoes Jeff Bezos's ideas, though it traces further to his mentor, Gerard K. O'Neill, and those massive O'Neill cylinders designed for habitation. You could propel such structures on long-haul trips. Generational vessels are feasible. Yeah, so here's my follow-up. Could Oumuamua be one of those? Well, possibly, though I'm not convinced. In Rendezvous with Rama, that sci-fi gem by Arthur C. Clarke, a top-notch read, the craft was cylindrical, about 20 kilometers across and 50 kilometers long. That's pretty close to estimates for, depending on the derived dimensions, of Oumuamua. That's quite a hefty topic, but the real query here is whether you've read the book and if you enjoyed it. Rendezvous with Rama. I haven't gotten through the novel myself. I first heard about it after finishing my paper on Moo, and folks suggested I give it a look. Now, I'm not big on science fiction because it so often strays from established physics principles. I prefer scientific work that sticks to the rules of physics as we understand them, letting my creativity flow within those bounds. It bugs me when stories dive into stuff that's, clearly unsupported by evidence. Well, plus, without any real feasibility, it just turns into fantasy. But solid hard sci-fi, like what Arthur C. Clarke pulled off, nailed that balance pretty well. Yeah, where you go, sure, there's a bit of believability to it. Not completely, maybe. He was absolutely a forward-thinking genius, full of insight, and I'd take lessons from a top-tier sci-fi author over a mediocre researcher any day. Now, my final question for you, Dr. Loeb. The Galileo Project. You've got a fresh observatory gearing up. Give us the rundown. Absolutely. Over the last 4 years, we've built out the structure for an observatory that scans the whole sky non-stop, covering infrared, visible wavelengths, radio waves, and even sound. That's a far cry from typical astronomy setups, which zero in on just a tiny slice of the sky at once. The goal? To spot any fast-moving things zipping through Earth's atmosphere. We aim to verify if every one is something we recognize, like man-made gear such as drones, balloons, planes, choppers, or satellites, or natural stuff like birds. Basically, hunt for any oddballs. To pull that off, we need to gauge the range of whatever our cameras pick up. That tech is rolling out in about a month, thanks to deploying several units per observatory that view the same sky target from varied angles. It's akin to parallax or triangulation methods. And hey, that's why humans have binocular vision, to gauge nearby dangers from predators, assess their proximity, and evaluate the risk. So, the Galileo project will deploy those multi-unit setups soon, and we'll begin pulling distance data. Right now, sans ranges, we're spotting a couple million objects annually. From that batch, without depth info, AI and machine learning tools, trained on known items, let us classify 97% as either artificial or occurring naturally. And as data piles up, those algorithms will sharpen even more. But nailing distances is key for calculating speeds or accelerations, so we can see if they fit the specs of everyday objects, whether crafted by us or from nature. Once that's in play, it'll revolutionize our approach, enabling per-object breakdowns and flagging true anomalies that defy our expectations of the familiar. I'm eager to uncover any such weirdos, especially since the Director of National Intelligence has submitted 3 reports on unidentified anomalous phenomena to Congress. I got asked to brief them on the Galileo project on May 1st, 2025, laying out our efforts, and I'm optimistic that in the next few months, we'll have stats to share on potential oddities. We're wrapping up 3 observatories, one already running at Harvard and Massachusetts, plus new ones in Pennsylvania and Nevada. We'll run them all and await results. The Galileo project also includes an arm focused on recovering fragments from interstellar meteors, those that slam into Earth at velocities signaling origins beyond our solar system. One popped up in 2014, flagged by U.S. government satellites, with details in a NASA catalog. We mounted an expedition to the Pacific to hunt debris. After examining what we collected, we spotted atypical chemical makeup in roughly 10% of the molten spherules we grabbed. A Netflix doc on the whole adventure and the tied-in Galileo research is slated for early 2026, sparking public buzz for grounded, evidence-driven science. Lastly, one of our newest pushes involves tapping data from the Rubin Observatory to seek interstellar visitors that might be tech-based. In the end, across all this, we're after solid proof of alien relics close to our planet that might reveal insights about cosmic companions. Yeah, kind of like spotting a tennis ball from the folks next door in your yard. Everything's lighthearted until that ball smacks you. Thanks for being here with us today, Dr. Loeb. And folks, be sure to grab Dr. Loeb's books. They're out there in all spots, packed with interstellar and extraterrestrial concepts, plus thoughts worth pondering. Dr. Loeb, are you aware you kicked off this program way back as our initial visitor? Feels like around 8 years or so. That's a real nod to your willingness to explore big ideas, and you've excelled at sharing scientific topics. You know, a couple months back on another podcast, someone quizzed me on my legacy. I replied, let it hinge on what I accomplish ahead, since the prime stuff awaits. In my view, I don't care about personal remembrance. What matters is capturing the chats I host. I've always regretted the scarcity of talks with Einstein, super limited ones, though you can hunt them down on YouTube these days. My goal is to record the voices of truly brilliant minds out there, those standing out. And that's key for extra purposes too, as a bunch of such recordings could, in theory, help build an AI model from that collection, letting it mimic the individual postmortem, like a digital stand-in that fields future queries drawing from their past thinking, actions, and logic. That's the path ahead. Pure future reality. Fingers crossed this session gets loaded into some AI down the line after I'm gone, so an online version of me lingers for conversations even when I'm out of the picture. Just cross fingers it's spot on and free from its own agendas to skew facts. Appreciate it, Dr. Love. Pleasure to chat. Event Horizon and my channel are hitting podcasts now on Apple Podcasts, Spotify, and YouTube memberships. Get early no-ad shows, extra specials, and chill-out material. Jump in today via the links under this to your fave service. Heat, heat, heat. Applause, music, heat. Music, heat, heat. Music.